Welcome to more learning with your boy StudyBoi. Yeah, that's what I'm calling myself. Still not proud of the name, but what can I say? Okay, so today I am here for some momentum. Yay, momentum. So this was a request from one of my friends. So here I am. Because they needed explanations in momentum. Anyways, momentum is a useful quantity to consider when bodies are involved in collisions or explosions. So you see, momentum is basically like going I don't know how to say, but how to keep your momentum and all that when you're basically running. Your mass doesn't change, but your velocity does change. Velocity. Yeah, a velocity is basically like speed of an object, how swift it is, how fast it is. Yeah, you can call that a velocity. So that, like Flash, if you have watched Flash, this would actually be very easy. So I actually recommend watching the Flash. Also, it's very fun for personal preferences. Now, it is defined as the mass of the body multiplied by its velocity and is measured in kilogram meter per second. So this right here is a unit. If you don't know what units, go check out my first video, which I probably uploaded yesterday or today, I don't know. Now that is the unit, and the formula is this: mass times velocity. Well, that's pretty easy. Now let's say let's give an example. Yeah, I'll give an example of a truck. Maybe let's say a truck has a mass of 100 kgs. Yeah, 100 kgs, and it's moving at the velocity of it's moving how fast is it moving? It's basically moving, let's say, 20 kilometers per second. So you multiply this 100 times 20, that it becomes 2000. That becomes the momentum. 2000, don't forget the units, kg, m per second, I guess. Wait, yeah. So you basically, I think, have to also, change the kilometers into meters, because that's a formula. I don't know what else to say. Well, we'll learn along. So practical work. Shows an arrangement which can be used to find the velocity of a trolley. Where is the trolley? Here it is. Now, if a trolley of length, this takes t to pass through the photo gate, its velocity equals to the distance. Well, that's interesting. Two photo gates are needed, placed each side of the collision to find the velocities before and after the collision. Okay. You can take the time to read the thing by pausing. Yeah, So, repeat the experiment with another trolley stacked on top of the before collision. Well, mass of I'm not gonna do that right now, maybe later on. Yeah, maybe I'll do that at the end of the video. Conservation of momentum. Well, when two or more bodies act on one another, as in collision. So that's collision basically. It's when things collide. And one object, two object move towards each other, and they basically collide. There's boom, basically like boxing, when two people's fists meet each other, they collide. That's collision. The total momentum of the bodies remains constant provided no external force act. So basically there's no friction, there's only one force acting, which is this but then oops. Yeah, so there's only two forces acting this way. Oh god. Yeah, so there's only two forces acting this way. One here another one here, but then there is no friction, like there is no opposing motion, you get. So they both remain constant if this is definitely not there. Yeah. Now this statement is called the principle of conservation of momentum. That's, I think the title made it pretty clear. Anyways, experiments like those in the practical work section show that it's true for all types. As an example, suppose a truck of mass 60 kg, okay, if you have an exam or any questions, yeah, I say it's actually the best to highlight it. I like the color. Actually, I'll just use yellow for it. Yeah, this one. Mass is 60 kgs. Okay. Moving in the velocity of 3 meters per second. Okay. Collides and couples with a stationary truck. Okay. Yeah, so for this formula to work, yeah, to use this unit, you have to change the kilometers into meters and wait, what? Yeah, kilometers into meters and turn maybe the hours into seconds if it is there, and collides and couples with a stationary truck of mass 30 kg. Okay, the two move off together with the same velocity. Okay, so it's basically like a car is going and another car is there. Okay, now by the time it reaches here, it basically takes it with it, so it's like a tow truck, but I don't know, like Thomas the train, I don't know, like a train. Yeah, train. The two move off together with the same velocity. Well, because they're basically acting as one body, you get. Now for this to get the total momentum of the two trucks, you get the momentum of truck 1 with the momentum of truck 2. So you add them, right? Wait, this is supposed to be 2. Yeah. So 60 kg times 3, because here's 60 and here's 3. That's truck 1. So that's 18. 6, 12, 18. See? 180 kg ms, or Newton meters as stated here. Where is it? Newton seconds actually. There we go. NS. You can actually use that. It's actually also pretty cool. So that will be 180 kg meters per second plus 30 times 0, which is 0, because math. You get. Now 180 plus 0 is 180. Well, there, done. That's pretty easy. So the total momentum after is, you can also just use this, 60 times this times velocity equals to 90. Oh, this to get the velocity? Yeah, this is definitely to get the velocity. Or the momentum, I don't know what you can call it. What is going on? Jesus. Oh, no, this is the total momentum before of the two trucks, when the two different bodies. Yeah, I get it now. So, yeah, this is basically that. So this is the total momentum of the two trucks before, when they have not yet met together. But here is a different case. So you get 60 plus 30. Okay, that is the total kgs. That's the total mass, because they're acting as one body now, times the speed at which is the speed at which they're going. But the speed at which they're going is the same, because the velocity is the same. So times velocity here, times velocity equals to 90 kgs. What? Wait, I don't think I've read the question, not gonna lie. 6, 7, 8, 9. Oh yeah, my bad. So this 60 plus 30. I thought this was actually like a mathematical formula or something. I don't know. My bad. So 60 plus 30 equals to 90. It's written here. times the v here. And since momentum isn't lost, like the mass doesn't change, the speed doesn't change, so the momentum doesn't change. I don't know if you're getting me, but yeah, because the mass of course does not change because the molecules in it still stay the same. If you want to know more about mass, please go to my first video. And well, the speed does not change at all. So, and those are the only two factors in finding momentum. So there we go. Since momentum isn't lost, 90 times v, there we go, you get this and put it here, equals to 180, because the momentum in the before is also 180, so just add that there, and then you will divide this by 90 and divide this by 90, and you cancel the zeros, and 9 divided by 9 is 1, 18 divided by 9 is 2. Answer is 2 meters per second, and that's the velocity, the speed, if that makes sense. Now, explosions. I mean, who doesn't like explosions, you know? Boom! Yeah. Now, momentum, like velocity, is a vector. Yeah, so momentum like velocity is a vector. Now, a vector is basically like the opposite of scalar. They're both quantities. Now, vector is something which in physics, yeah, it is something which has both magnitude and a direction. Now, I think magnitude is basic. Okay, let's say this line. The magnitude will be, well, that, and it has a direction which is going this way. So it's a vector, I guess. I guess I'll just have to make another video on it next time. Yeah, the next video will be vectors and scalar quantities. It's a vector since it has both magnitude and direction. Vectors cannot be added by ordinary addition unless they act in the same direction. So if it's this, if there's an arrow like this and there's an arrow like this and there's another arrow like this, you can't add this and this. You can't add this and this in a, like, you can't add those in a, or as an ordinary addition. You can, but you can add this and this together. You can just forget about that. Shoot, no one wants you. Yeah, there. Okay, so the smaller subtracts from the greater. Oh, if they act in exactly same direction. So like if they both act, if they both are north, you can, the smaller one subtracts from the greater. So maybe this is 5 and this is 2. The thing will be 3, I guess. Yeah. If you want to know more about vectors, just go to my next video, I guess. Wait for it. Now, momentum is conserved in an explosion such as occurs when a rifle is fired. So an explosion doesn't only mean big boom like nukes. It also occurs in small things, everyday things like guns. Not like guns are everyday things, but still, you get the point. Before firing, the total momentum is 0 because, well, you haven't fired it. There's nothing moving. Okay, since both rifle and the bullet are at rest. If you want to know how guns work, I don't know. Don't go on YouTube. It's illegal. I don't know if it's illegal or not. Just study, I guess. Maybe go to the army. Yes, you know. Salute to those guys who are in the army. Protect us, all that. Anyways, during the firing of the rifle, the bullet receives equal but opposite amounts of momentum. That sounds like Albert Einstein. What Albert Einstein said: every action has an equal and opposite reaction. But who knows? Are we in physics? Not like we're in physics. Oh wait, we are. Never mind. So, anyways, equal. Both during the firing, the rifle and the bullet receive equal. Let me even highlight that. You know, in a blue. Equal. There. But opposite amounts of momentum, so that the total momentum after firing is still 0. Yeah, so that's what it means. Like, there's a momentum acting this way and there's a momentum acting this way, and when you add them together, well, maybe let's say this is plus 2, this is negative 2, because it's moving in a different direction. When you add these things together, it becomes 0, and there's no motion at all. Yeah, that makes sense. If the rifle fires a bullet of mass 0.01 kg with a velocity of 300 meters per second, damn, that's fast. Now, forward momentum of the bullet is the mass times the speed or the velocity. Answer will be 3 kg meters per second. That's the momentum of the bullet. Now, the backward momentum of the rifle is still equal to 3 kg per second, because you don't just go flying off. I mean, pretty sure if you like shoot, yeah, okay, you still have some recoil, but still, like, it's still less. You don't just go flying backwards like a rocket or something. Yeah, I just know this because I play Call of Duty. Go watch my second channel. I do gaming there. If the rifle has mass m, it recoils, kicks back, there we go, with a velocity v, such that mv, mass times velocity, which is the momentum as well, equals to 3 kg meter per second. Taking mass 6 kg gives velocity 6. What? Here we go. So mass times velocity equals to this. Now, here you have the momentum, and you have the mass. You want the speed. You want the velocity at which there's a recoil. So basically, you get this. You get the momentum over, which is 3, and you put it over the mass, which is 6. So mass over what? Momentum. Mom over not mom, but moment. There we go. More men. Moment. But moment is a different thing. Momentum. There. I'm too lazy to write the full thing, but still. Okay, so momentum over mass equals to the velocity, in a way, I think. I mean, that's what the book says. I mean, I'm just explaining the book. Well, there we go. So the answer will be 0.5 or a half, because, well, 3 divided by 3 is 1, and 6 divided by 3 is 2. 1 over 2, which is 0.5, which is also half. There. Rockets and jets. For all those pilots and engineers out there, if you release an inflated balloon, pretty sure that's not a rocket or a jet, but still, with its neck open, well, it flies off and also makes farting noises, but still, in the opposite direction to that of the escaping air. Well, balloon, that just looks okay. Balloon, this is the air, so it moves this way because the air is pushing out this way, making the balloon move this way. Yeah, that makes sense. You just go and do that with an actual balloon. It'll be easy to understand. Now the balloon has momentum to the left, and the balloon moves to the right with equal momentum. This is the principle of rockets and jet engines. In both a high velocity stream of hot gas is produced. Oh, so basically a rocket is just a large scale balloon, and air is really, really hot gas. I mean fire. I mean, I don't know. There we go, a better balloon. Nice. So you can see the air going this way and the balloon goes this way. Makes sense. By burning fuel and leaves the exhaust with large momentum, the rocket or jet itself acquires an equal forward momentum. So, you know, if the air is pushing this way with the momentum of, let's say, 3000 kilometers per second, I think that's what jet is. I don't know. Yeah. So not dollar but second, 3000 kilometers per second. That's what the air exhaust is going backwards. So the rocket, oh boy. Okay, so the rocket moves this way with 3000 kilometers per second. Yeah, that's what it means. Space rockets carry the oxygen supply. Jet engines use surrounding air. Wow, that's actually extra information. That's nice. Well, yeah. Now force and momentum. Steady force F acting on a body of mass m increases its velocity from u. Okay, well, let me just stop doing all this and let me just highlight the key points as I said. Now, steady force F, we can make that, so we're going to get confused later on. Mass m increases its velocity from u to p, u to v, I mean, in time t. The acceleration u, well, okay, this is given by, this is the formula basically. Okay, so what does this mean? Let's see. Now this is the acceleration. So you're basically getting acceleration, yeah. Acceleration equals to, we can put this as change in momentum, because it's basically increases its speed. This was the first speed, this was the second speed, yeah, over the time. That's how you get acceleration. And you get this by doing some simple math. This basically velocity equals to acceleration plus thing what velocity equals to the first time, velocity equals to original time plus acceleration plus the time. Oh wait, times the time. I don't know if that makes sense. So let's say if a steady force F acting on a body, let's say a car, okay, of mass 200 kilograms, increases its speed from 200 kilometers per second to 300 kilometers per second in 2 minutes. The acceleration is, well, you just do that, you work it out. Yeah, therefore, oh, this would have actually made more sense if I actually did do. I should just read before actually explaining. That will make more sense. This is another version of Newton's second law. For same problems, it is more useful than F equals to force equals to mass over acceleration, I'm guessing. We also have force times time equals to mass times velocity minus mass times the first time, I guess, I don't know, where mv is the final momentum, mu is the initial momentum, and ft is called the impulse. So this is what you call the impulse. Okay, so the impulse is basically the difference between the initial momentum and the final momentum. That makes sense, right? Because, well, you get the acceleration this way and all that jazz. I don't know how else to put it. So you basically have to get the change in momentum. You get momentum 1 and momentum 2, and the difference between them is called, where is it? Impulse. Yep, definitely. Nailed it, people. Nailed it. Nailed. Nailed it. Now, sport. Well, for all of you sporty fans out there, here's something you can understand. Okay, impulse and collision time. A good cricketer, a very good interesting sport from India and other countries, or tennis player, I don't know where it's mostly from, but okay, follows the good cricketer or tennis player follows through. There we go, follow through. If you play golf, if you play, well, badminton, tennis, cricket, you should know what this means with the bat or racket. You basically keep swinging to keep the momentum on. Like if you hit the ball here, let's say you're swinging the bat. This is the bat, the way it swings, and you hit the ball here. You don't just stop, because then the momentum will get spoiled and the ball won't reach far. But if you keep swinging, the ball will actually go farther, or whatever the thing will actually, whatever you're hitting will actually go farther. Now the force applied, this is because the momentum is, well, it's intact. The force applied then acts for a longer time because the impulse is greater. Meaning, well, what we said, the impulse is basically the initial momentum minus the final momentum. Now the initial momentum, let's say this will always remain 2, but if you increase this, if you increase the time of the final momentum by 5, and so the impulse will be 3, but if you don't follow through, the final momentum will be, let's say, 3, and 3 minus 2 is 1, meaning this will have a greater impact. Yeah, I think that was a good explanation. Hats off to myself. Yep. High five to myself. Yep, there. Now when we want to stop a moving ball, such as a cricket ball, slippers, if you have really tough parents, they'll just throw slippers at you if they're angry, or anything they find inside. But anyways, if you want to, I have very good experience with that. If you want to stop a moving ball, such as a cricket ball, however, its momentum has to be reduced to 0 for it to actually stop. Well, there's a guy, some guy playing cricket. I don't know what team he is. An impulse is then required in the form of an opposing force, using for a certain time. Now, if you watch cricket, let's say, the cricketers actually pull their hands while catching the ball. There we go. See his hand? That's how they do it. Yeah, there's also a picture here, but the clip actually would give a better example. Now there's also a long jump explanation, but I think this jump will actually be better. So now I think that was all on momentum today. Yep, that was all on momentum. See if you can actually answer these questions. Please drop a comment down below. I know my first video actually you couldn't drop a comment because, well, I messed up. Yeah, but this time I'll actually make sure to have the comments enabled. Sorry for that, and please subscribe and like the video if you do, and peace out.